We was discussing about if the relative motion of two masses. If two masses are moving, then how you may find the relative velocity and other things. Okay. The first of thing is that we will discuss is about the inertial frame. Inertial frame. What is the meaning of inertial frame? Yes.
इसमें acceleration
Yes, ऐसा frame जिसमें acceleration ना हो, ठीक है? So if mass is moving with the if the frame of reference is, ठीक है? If the frame of reference is with the masses attached with the masses moving with the constant velocity or constant speed, okay, and their direction is not changing, okay, if they are moving with the constant velocities, then that will be defined as an inertial frame. Why inertial frame is important? Anyone may answer why the inertial frame is important. What is the difference between the accelerated frame and inertial frame? Yes. One difference is that acceleration means they are changing in velocity. Okay, velocity is increasing or
वो frame of reference होगा जिसमें acceleration zero होगा वो निश्चित frame of reference होगा. The uniform velocity को जितना होता है.
Okay, if something is moving with the uniform velocity, okay, if that is closed from inside, okay, if there is no jhatka matka, okay, if that is moving with the constant velocity, there is a constant velocity, means there is no change in direction, their speed is not increasing or decreasing. Then, if you are not observing things from outside, okay, if there is no relative motion, if you are not observing any relative motion, then you will always experience the velocity is zero. If, for example, if you have a car, okay, if you have a very good car like a BMW or Mercedes, okay, not like Corolla or others, okay, when it move on the road, okay, so that there will be and if it is moving with the constant velocity, even its speed is 100, 140, 150, 160 kilometer per hour. Even 350 per hour.
सर एक मिनट में बता दें frame of reference होता है.
मैं बताऊँ. Frame of reference, the reference attached with the जिससे भी आप observation कर रहे हैं या जिसको भी reference के तौर पे कर रहे हैं, तो that will be defined as a frame. For example, if mass, if this car is moving, ठीक है, and if you attach if you are using as a reference point, if you are studying this motion, and if you attach this some reference axis, x-axis, y-axis and z-axis, and if you treat it as a frame of reference, then this motion, this car will be treated as a frame of reference.
कार will be treated
yes, because इसके center में जो भी आपने axis बनाया है, x, y and z, okay, so then this axis will be जो उस कार के साथ attached है. आप imagine कर रहे हो ना, वैसे तो कार आप as a reference use कर रहे हो. So this axis will be defined as a frame of reference. If this car is closed from outside and from all around, and you are not observing the outside, the motion of the outside things, okay, then what will be happen if that is moving with the constant speed, even its speed is 360 kilometer per hour, okay. If it is moving a very fast, moving with a very high speed, but you will experience that it is in a stationary position. It is not moving. Its velocity, you will experience that its velocity is zero. नहीं समझे? चलो, timing इस बात को सच मान के बताओ. अब इस you are standing on this earth. You know that you are sitting on this earth, ठीक है? And this earth is rotating with some speed, okay? And that is also orbiting, ठीक है? But have you experiencing its motion? So that's my claim. Okay, not my claim, but that was the Galilean claim. If something is moving, if you how you feel that something is moving or not. You observe that something is going toward backward, ठीक है. जब आप गाड़ी को सफर कर रहे हो, पीछे देखते हो बाइक पीछे से पीछे जा रही है, तो आपको लगता है आपकी गाड़ी चल रही है, ठीक है. थोड़ा बहुत गाड़ी के अंदर हल्के हल्के झटके से फील होते हैं, then you experience that your car is moving. बट मैंने कहा कि अगर आप डिफरेंट कार्स को लो, मिसाल के तौर पर मेरान पे आपको 100 की स्पीड भी बहुत ज़्यादा लगेगी, ठीक है. आप करोला पे आपको 120 की स्पीड कम लगेगी. आप इसी तरह BMW या मर्सिडीज पे जब सफ़र करते हैं तो वो लगता है चल ही नहीं, बहुत स्लो चल रही है. मीन इसका मतलब है कि एक्चुअली अगर कोई ऑब्जर्वेशन बाहर की ना हो, इफ दैट इज क्लोज फ्रॉम ऑल साइड्स, देन यू कांट एक्सपीरियंस द मोशन. दिस इज लाइक इवन ये 3 किलोमीटर पर आवर है, ये इक्विवेलेंट है इसी तरह जैसे इसकी स्पीड 0 किलोमीटर पर. ओके, अच्छा. बट व्हेन इट स्टार्ट टू एक्सेलरेट, जितनी भी अच्छी गाड़ी, इफ इट स्टार्ट टू एक्सेलरेट, इफ इट्स स्पीड इज इंक्रीजिंग, मीन or decrease. There is a retarding acceleration. If the speed is decreasing. If increasing, you will feel the pull backward. Okay. If speed is decreasing, you will move forward. So, if increasing, you will experience the pull backward. ठीक है, ओके. आपको पीछे की तरफ झुकना पड़ेगा, गिरोगे, ठीक है. बट इफ स्पीड इज डिक्रीजिंग तो आप आगे की तरफ गिरोगे. मतलब आपको गिरोगे तो नहीं, लेकिन बट एक एक्सपीरियंस होगा कि इस तरह आपको पता चलेगा कि गाड़ी इवन दैट इज क्लोज, यू विल एक्सपीरियंस दैट कार इज स्पीड इज इंक्रीजिंग और डिक्रीजिंग. So, if the frame is accelerated, you will always experience the motion. But if the speed is constant, then you will not experience any motion. जब तक आप बाहर ना हो. ये बात क्लियर होगी या नहीं होगी? ठीक है, ये हमारा. इसको मैं साफ कर सकता हूँ. Okay, now the topic is relative. ये पिछला हम थोड़ा सा रिपीट कर रहे हैं, ठीक है. Now the topic is what will be happen when two masses is moving and relativistic, मतलब they are belong to the inertial frame. Inertial frame, no you can understand. Mean जिस चीज को हम कंसिडर कर रहे हैं फ्रेम, जिसका रेफरेंस ले रहे हैं, जिस चीज को कंसिडर कर रहे हैं उसे हम फ्रेम ऑफ रेफरेंस करेंगे. Inertial frame, if two bodies are moving with the constant speed, the speed is not increasing or decreasing. Okay, if two masses are moving with the constant speed, it means if there is acceleration, if there is no acceleration, if acceleration is 0, there is a velocity. Velocity may be a very high velocity. I'm not supposing that they have a very slow velocity. They may have a large velocity, like a 360 km per hour. ठीक है, 450 km per hour. ठीक है, about the inertial frame, if there is no acceleration. ठीक है, listen. Inertial frame are the frame when there is no acceleration, okay, or no acceleration mean का भी लिखने, no acceleration mean zero velocity, okay.
No acceleration means zero velocity.
Oh, sorry, constant velocity, uniform velocity. Sorry. So, if you have two masses. Firstly, we have to study what will be the motion of. If there is a single mass, okay, mass m. The recorded lecture will be also available on YouTube. If you have missed something, and then you may write again from watching the lecture. Okay. So if this mass is moving along, if some mass is moving along the line, okay. Okay, and if this is the if the R1 is the first position and R2 is the final position of single mass 1, okay. This is R1, this is R2. and this will be this will be, I have already explained, if you consider R3, it will be equal to actually the delta R, okay, already explained, okay. So because this delta L is not equal to delta R, okay. This is scalar, this is not equal, we have to divide it into the small patches, okay, and when we have to divide it into the small patches, okay. And that will be a delta R1, delta R2, and that will be delta L1, that the curve along the curve line, that will be arc will be lengths, okay, and so they are Rn and delta R and delta Ln. Even then, if we divide it into the small patches, they will be not equal. Even then, if we divide it into the small, even if we divide it into small patches, delta R will anyone Ri will be not equal to delta L, as we know that even small patches, they are different, okay. So this arc length is this is delta this is delta R1, and this is delta L1, this is delta R2, this is delta L3, L2, this is 3, and this will be delta R3, okay. So that have a difference. Delta Ri will be not equal to, and different R's will be also different. This length is different, this length is different, But if we approach, if delta Ri approach to 0, okay, then this will become delta Ri. Then this delta Ri will become delta R, and this will become a delta L. So this change will be along the line. And when we integrate, then we can get the total length. I have already explained. Okay. So this will be the motion of the mass, single mass, when it moves, and that will be treated as. So this will be motion along the path. Okay, and we may calculate the motion along the path. I have already explained in a previous lecture. Okay, but okay, now may I log it? I think if you have noted it, because I need this space. If you have two masses, okay, now that was all about the single mass, okay, and this will be a delta R, okay, and delta V, what will be the V? V will be velocity. What will be the velocity? I have already explained that when you take the derivative delta R I approach to 0, delta R I approach to 0, and this delta R I changing with respect to t, okay, time. Okay, so then that will be a dr over dt. Okay, so that will be the velocity, and in the same way we may find the acceleration. Okay, but we are not interested to find the acceleration now. Okay, but if you have a two masses, that is the single mass, and this is the. If you have a, what will be happen if there are two? The last thing was about the one mass, but if you have a two masses, okay, if you have two masses. And what will be the relative motion between the two masses? If these masses may be moved in this way, and these masses may be moved in this way, there will be two different. Okay. If you have anyone have a color marker? Okay. Okay. If this will be, as I have already explained, this will be R1 position vector of the. If I say that this is the position vector of first mass, and if I say that this is the position vector of second mass, R2. Okay. As we have already explained, if I consider that this is the motion of mass 1, this is the motion of mass 2, then according to this formula, okay, by using this, if I say that this is equation A, then according to this equation A, according to, if I say that this is figure 2, okay, so according to figure, this is equation fig 2, but according to fig 1, I have already drawn, okay, and erased, that is fig A, fig 1, okay, and equation A, okay, if that is equation A, then according to this formula, velocity will be velocity of first particle. And if I say that is not, because I have used the R1 as a position 1 and R2 as a position 2, I say that this is the mass A, this is mass B. If I say that the velocity of A mass is RA and velocity of B second particle is 2, okay. So according to fig 1, which I have already erased, okay. So according to equation A, then VA will be dRA over dt, okay. So this will be the velocity.
frame of reference
The frame of reference means this is first frame of reference, this is one frame of reference is attached with this, and one frame of reference is attached with this. Leave it, okay. Timing to try to understand it, okay. This is mass 1, this is mass 2, and this is mass, okay. अभी आप frame of reference,
इसमें frame of reference use,
मैं बता frame of reference यूज हो रहे हैं, मैं बता देता हूँ, अभी आप उसको भूल जाओ, ठीक है. Frame of reference का क्या मतलब मैं आगे बताता हूँ, ठीक है. अभी आप ये देखिए, अभी वो थोड़ा आपके लिए थोड़ा मुश्किल है, इसलिए थोड़ा अभी तो नहीं परेशानी हो रही है.
परेशानी तो हो रही है क्योंकि फ्रेम ऑफ रेफरेंस यूज आ रहा है.
मैं अभी जिक्र नहीं कर रहा ना फ्रेम ऑफ रेफरेंस. अब यहाँ जो कुछ मेंशन हुआ है इसकी समझ आ रही है.
लास्ट में फाइंड करने लगे ना मैथ्स 1 के मैथ्स 2 की विद रिस्पेक्ट टू जो
मैं विद रिस्पेक्ट टू दिस ओनली,
अगर यूनिफॉर्म रास्ते में मूव कर रहे हो तो फ्रेम ऑफ रेफरेंस यूज होगा, वो इनिशियल फ्रेम ऑफ रेफरेंस होगा.
और इस जहाँ जिसके रेफरेंस से ले रहे हैं वो आपका फ्रेम है. यहाँ आप वेलोसिटी ये निकालिए इसलिए
ओरिजिन के हिसाब से, ओरिजिन यहाँ पे जो भी फॉर एग्जांपल दो गाड़ियाँ मूव कर रही हैं, एक मैं उसको देख रहा हूँ, मैं फ्रेम ऑफ रेफरेंस हूँ इस हिसाब से.
नहीं हाँ बिल्कुल सही कह रहे हैं. यानी अब हम इसकी पोजीशन इसके हिसाब से निकाल रहे हैं ना, फ्रेम ऑफ रेफरेंस जिसके मुताबिक निकाल रहे हैं, ठीक है. अभी हमारा फ्रेम ऑफ रेफरेंस जो है वो O है, और एक ही
जो ऑब्जर्व कर रहे हैं दो में से जो
मोशन को ऑब्जर्व कर रहे हैं, ठीक है. तो आपके पास एक पार्टिकल का जो वेलोसिटी आ गई अकॉर्डिंग टू दिस फार्मूला, ठीक है, दैट इज डेल्टा आर ए, ठीक है, ओवर डेल्टा टी, डेल्टा आर अप्रोच टू डेल्टा टी कर लो या डेल्टा आर कर लो, क्योंकि डेल्टा आर इज चेंजिंग विद रिस्पेक्ट टू टी, तो डेल्टा टी अप्रोच टू 0, ठीक है, ओके. सो दिस विल बी आर डी आर ए ओवर डी टी, ओके, गॉट इट. Similarly, for a second particle that is mass b, similarly for b mass b, you have vb that will be equal to limit. Yeah, this is the limit, okay. The limit delta t approach to 0, and this will be a delta rb over delta t. That will be a drb over dt, okay. So that will be a two masses, okay. That will be about the two mass motion of two masses, but it is with respect to, as I have, it is with respect to this is velocity of mass A with respect to what is the frame of reference with respect to origin O, and this is velocity of mass B with respect to origin O. Now frame of reference is fixed, okay, O, okay, got it.
फ्रेम ऑफ रेफरेंस आपने बताया दो फ्रेम ऑफ रेफरेंस होते हैं.
नहीं, दो मैंने नहीं कहा, ठीक है, वो अभी आगे पढ़ेंगे, ठीक है. अभी आपने ये पढ़ा है कि अगर ये O है, इसके मुताबिक A की वेलोसिटी क्या निकलेगी, इस O के मुताबिक B की वेलोसिटी, सिर्फ इतनी बात, ठीक है, ओके.
यानी कि जो ऑब्जर्वर होगा वो फॉर एग्जांपल वो स्पीड फाइंड करेगा कि मेरे हिसाब से इसकी स्पीड क्या होगी और इसकी स्पीड क्या होगी,
बिल्कुल ठीक है, Okay. अच्छा, now this is the according to A. Okay. If I say this is equation 2 and this is equation 3. Okay. Okay. If we observe this closely, okay. Okay. A1 is moving freely. This is A, and B is moving free. At some point, at every point, the position is changing. Okay. This is mass. This is mass A. This is mass B. Okay. Initially, there is continuously change in here is 0. So at every point the distance is different. Okay.
Yes, sir.
So if but every point this at this point this is different, this point different, at some point that is 0, that is large, at some point that is change, but it is changing with passage of time. For example, at 2 p.m. they are here, at 3 p.m. here, at 4 p.m. here, at 9 p.m. here. So as the time will be changed, with changing the time, the difference will be changed. Not necessarily that will be increased or decreased. They may be at some time that will be increased, at some time they decrease, but they will be vary with respect to time. So it means this difference that I have already proved in the previous, that will be according to head and tail rule, that will be a delta. Okay, and this difference will be if this arrow is toward B, this difference will be BA. Okay, if arrow is toward B, then this difference will be defined as delta. Actually, RB is the resultant according to head and tail rule. Okay, and RA plus delta RAB. Okay, BE. Yes, and delta RAB is actually what is the delta RBA? That will be according to head and tail rule. According to phase 2 and head and tail rule. Okay, this delta B will be RB minus RA. Yes?
Yes, sir.
Yes? Okay. This will be equal to this. Okay? And similarly, and this delta RB क्या है? What is the delta RB? Position vector of mass B with respect to A. Okay, and this is changing according to 3. It is changing with passage of time. That will be function of time. Okay, so this delta RBA must be function of, how you write as the function of t. That must be, why that must be a function of time, because it is varying with the passage of time. Okay, because yes, it may be increase, it may be a decrease, but it's changing with as the passage of time. But if time is same, if you are standing, if there is no change in time, then this change will be not changed. This will be constant. अगर time भी change हो रहा तो वो constant रहेगा. आपके दरमियान और मेरे दरमियान जितना फासला, अगर टाइम नहीं गुजरा तो आपके और मेरे दरमियान वो फासला उतना ही रहेगा. But as passage of time, that will be increase or decrease. Okay, so that will be the function of time. Okay. Similarly, Similarly, RAB will, what will be RAB?
Position of A with respect to this.
Yes. The position vector of A with respect to B. Mean now this section will be this. Okay. Sorry. This was delta R B and this will be delta R AB. This direction will be opposite. Okay. And according to head and tail rule, now RA will be resultant. RA will be resultant, and the RB will be the components. Okay. RA. Yes. RB plus RA.
सर दो बार डेल्टा का सर ऊपर डाल बोल गाया नहीं आपने डेल्टा आर
No, it's good. Okay. ठीक. So RB and delta RA. सबको समझ आ गई?
यस सर
Okay. So delta RAB will be equal to RA minus RB. Okay. And if we take common, then RB minus RA. On delta RAB will be this. And this, what is this according to
Delta RBA.
this is minus delta RBA. Okay. So this will be delta RAB. Okay. Okay. So how we may find the velocity of A with respect to B and B with respect to A? We know that will be when we take a derivative delta RAB over delta T minus delta RBA over delta T. May we divide it? Okay. Okay. And when we apply the limit, why we apply limit, I have already explained. When we apply the delta t equals to 0 and when we apply the delta t equals to 0, this will be RAB dot, as I have already explained, dot mean time derivative, and this will be VAB. Okay. Also, and this will be a minus VBE. Okay. So this velocity will be opposite. Okay. And what will be the, according to, if I say that this is equation, what is equation 3, and delta and VAB will be VAB will be, what will be the VAB? That is that is I think what will be VAB? Actually, we have to find the value of VAB. That is velocity. Now we are not using the origin. We are using the
with respect to जो वीडियोस के हिसाब से निकासी करेंगे जो सिर्फ वीडियोस के वर्ष हो जाएगा हम भी सेम
बिल्कुल you are absolutely okay. This VAB, that is delta RAB over delta t, okay, limit delta t approach to 0, that is equal to limit delta t approach to limit delta t approach to 0, rb, okay, you may write as this is drb over dt, sorry, this is derivative, okay, dA, okay, this will be drba dt, okay, the sum formula will be applied derivative, ठीक है, आप इसका डेरिवेटिव ले रहे हैं, इस साइड का डेरिवेटिव ले रहे हैं, तो दिस विल बी इक्वल टू dr b माइनस dra ओवर dt, आप तो मैथमेटिक्स के एक्सपर्ट हो, ठीक है, सो दिस विल बी b dot minus ra dot, so this will be, what is this, this is vb minus va, so this is vba, okay, and vab, what is the vab, that is va minus v, so this was the two results, and both velocities are we have already proved that both velocities will be have same magnitude of the opposite, okay, so that was the result. But this was a very simple case, okay. Now if there is a third person involved, okay, if one mass is moving and there are two observers, okay, there are two frame of references, then what would be, okay, if there are two different observers, in first case there was only one observer, now if there are two observers, okay, so if motion of a mass observed by two distinct observers. Distinct means different. Observer mass of motion of mass observed by two distinct observers moving with constant relative to each. Now I have already stated that you must be vague to get the answer of your question. About the frame of observer, when we will talk about the observer, that will be treated as a frame. If they are moving with constant speed, if there is if their velocity with respect to each other is constant, then that will be defined as inertial frame. Mean if you have if A is one observer, B is other observer, no observers. If you are and they are observing something like kite is flying. If you think that we are plane is okay flying, okay, they are observing, two person are observing. Okay, is it possible? Okay, and if these observers, these are the inertial observers, the inertial frame of reference are attached. Inertial frame mean their relative velocity, mean the velocity of, this is velocity, okay. If this is A, this is B observer, okay. The velocity of B with respect to A is constant, not not changing. Okay, that is not function of time. If velocity of B with respect to A is constant and velocity of A with respect to B is constant, then that will be defined as a inertial frame. Okay, if there are two observers A and B, the relative velocity is constant. This is constant. Constant means uniform. There is not accelerated frames. Okay, they are not. Their speed is constant with respect to each other. Okay. So this is constant, and the Vb is what is the Va? Velocity of B with respect to A. Okay. Yes. Second particle key with respect to pairs. This is observer A, this is observer B, this is observer A. Okay. What will be distance between A and B? Okay. This will be direction dBA. Okay. What will be the direction position vector of this plane with respect to A? What will be the position vector? If I is saying that this is observer and this is the mass one, any mass. This mass is moving with respect to. I have already told we take the position vector, and this will be RA. The RA is position vector of plane with respect to A. RB is, now this RA is different. Not like a previous exercise. This RA is position vector of plane with respect to mass A, observer A. Mass A means observer A. यहाँ एक बंदा बैठा हुआ दिखा सकता है, एक ऑब्जर्वर यहाँ बैठा हुआ, दोनों जहाज को उड़ता हुआ देखते हैं। फर्क ये है कि ये थोड़ा जमीन भी कर रहा है, या साइकिल पे बैठा हुआ है या कार पे बैठा हुआ, इसकी कोई स्पीड है, ठीक है, लेकिन वो कांस्टेंट स्पीड है। हम एक्सेलरेटेड फ्रेम लेंगे, ठीक है, फ्रेम ऑफ रेफरेंस जिससे ऑब्जर्वर लेंगे। ऑब्जर्वर की स्पीड जो है वो क्या है, कांस्टेंट। तो इन दोनों की एक दूसरे की B की A के लिहाज से और A की B के लिहाज से वेलोसिटी क्या है, वो कांस्टेंट। ओके, तो वेलोसिटी ऑफ B विद रिस्पेक्ट टू A एंड द सेकंड कंडीशन इज इट इज कांस्टेंट, मीन दैट इज नॉट चेंजिंग। किस रिस्पेक्ट विद रिस्पेक्ट टू टाइम। टाइम के हिसाब से चेंज नहीं होगा, ठीक है। टाइम जितना भी बढ़ता जाए, इसमें अपनी कार की स्पीड जिस कार पे चल रहा था 2 किलोमीटर पर आवर या 10 किलोमीटर या 100 किलोमीटर या 1000 किलोमीटर पर आवर, इसकी स्पीड जो है वो कांस्टेंट है, वो चेंज नहीं। So what will be the result? So this will be RB. अब क्या होगा? अच्छा, ये तो इसकी वेलोसिटी है, लेकिन ये पोजीशन वेक्टर नहीं हो सकता, सॉरी दैट्स मिस्टेक, ठीक है। VP ये पोजीशन वेक्टर नहीं। वेलोसिटी जो होती है उसका यूनिट क्या होता है, मीटर पर सेकंड, ठीक है। पोजीशन वेक्टर का जो है यूनिट क्या है, मीटर। अकॉर्डिंग टू लीनियर अलजेब्रा कोर्स, द सेम वेक्टर same class of vectors will be added in the सेम क्लास
पोजीशन वेक्टर का यूनिट क्या है?
मीटर जा रहा है पोजीशन
ठीक है, वो लेंथ
डिस्टेंस लेंथ किसमें मीटर में डिवाइड किया जाता है। तो यहाँ भी लेंथ होनी चाहिए ना, ये लेंथ है ये लेंथ है, यहाँ भी लेंथ होनी चाहिए ना, तभी दे विल बी ऐड और सब्ट्रैक्ट। In linear algebra course we have studied that the vectors belong to the same class will be added and the resultant will be belong to also in the same class. ऐसा ही है। So that unit will be not changed. Okay. So if these are the position vectors, these are the position vectors. This must be a position vector. But I have used the velocity. That is wrong. Okay. But यहाँ velocity होनी चाहिए। Sorry, distance होना चाहिए। तो distance क्या होगा with passage of time? ऐसे चेंज इन वेलोसिटी पर यूनिट टाइम, चेंज इन पोजीशन विद रिस्पेक्ट टू टाइम। ठीक है, यानी ये जो आर ए बी है डेल्टा आर ए जी, ये किसके बराबर होगा? वी ए बी डेल्टा। ऐसे ही है ना?
ये कैसे करेंगे?
कैसे करेंगे यार? चलो ठीक है, वी ए बी इज इक्वल टू डी आर ए बी। ये तो भी निकालना है,
तो वेलोसिटी
ऐसे ही है ना? वेलोसिटी को यही डेफिनेशन पढ़ा, अभी पीछे प्रूफ किया है ना, यही है ना? अच्छा, हमने बी ए लेना है, तो बी ए के लिए मैंने क्या किया था, ये अभी निकाला था, ये पीछे निकला हुआ, ठीक है? ये बी ए ऐसे ही है, ऐसे ही है। ओके, डी आर ए बी ये किसके बराबर होगा? वी बी ए ऐसे। तो यहां क्या आ गया?
यार वो तो मैंने कर दिया वेलोसिटी।
Okay, so this will be your dr, this will be your dr, ठीक है? Okay, and
सर इसमें हम फाइंड क्या करने जा रहे हैं ऑलरेडी?
ये अभी जरा सबर क्या करो मुझे, ये जो चीज है आपके पास, ये डी आर और इसकी डायरेक्शन क्या है? ये जी से, ठीक है? नाउ इट्स क्लियर? ओके।
नो सर, सर आपने डी आर पे लिखे ए बी और बी पे लिखे हमने बी।
अच्छा, ये सॉरी दैट्स माय मिस्टेक, यू आर राइट, दिस इज बी, दैट वाज द राइट the position डी आर ए, okay? So RA according to head and tail rule, head is joining with the head of this and tail with the this tail. So RA is resultant of this and this. Okay? So RA is actually the resultant of VBA dt plus RB. Okay, very simple. Why this VBA dt? This according to this. Or you may write, if you are you may write in this way, that VA plus RA. Okay. dr BA plus RB, okay, and this dr BA is R okay. Okay, this is relationship, simple. If we take derivative, then VBA is constant with respect to time. So derivative of VBA with respect to time, that will be 0 constant. So this will be a VBA plus RB. Yes? Oh sorry, wrong. Yes ऐसे कह रहे हो, गलत लिखूंगा तभी जाएगा। इसका भी तो डेरिवेटिव, इधर डेरिवेटिव अप्लाई हुआ है तो इधर भी डेरिवेटिव, dt का डेरिवेटिव dt के रिस्पेक्ट 1 होता है। तो दिस विल बी अ dRB dt. Okay, and this will be VA will be VBA plus
ये लास्ट ईयर VBA ये 0 नहीं हो जाएगी क्योंकि कांस्टेंट लास्ट है ना B के रिस्पेक्ट में वो
derivative is all derivative are a linear function, non-linear function linear function है, linear algebra नहीं पढ़ते हैं। चलो छोड़ो यार, c x का डेरिवेटिव निकालो, क्या आएगा? यही नहीं आएगा, उसके साथ वेरिएबल मल्टीप्लाई
लीनियर हो गया
इसे लिखें, या खैर या मैं sin x लिख लेता हूँ।
ये नहीं आपका क्वेश्चन ही मेरा मैंने कहा लास्ट तो 0 होगी पॉइंट भी
वही वो कांस्टेंट है ना, तो वो क्या आएगा? ये कांस्टेंट बाहर आ जाएगा, dt ओवर dt आ जाएगा, dt का डेरिवेटिव
लास्ट ये वो तो 0 है या फिर dt ओवर dt जो भी वो खत्म हो जाएगा dt की जगह हम 0 नहीं पुट करेंगे।
and VB, if you are interested to find the velocity with respect to moving particle, V is moving, okay? If it is stationary and if it is moving, and if you want to find this with respect to, then VB will be equal to VA minus VBA. Okay. Okay. If in exam I ask find the velocity of plane with respect to A, then this will be formula. And if I ask about the velocity of plane with respect to second mass, then this will be a formula. Okay. So this will be your two results. Okay. This will be a Z1. This will be called Z2. Okay. What about the acceleration? The velocity will be velocity of plane with respect to A observer will be different. Velocity of observer plane with respect to observer B, that will be a different. Okay, but what will be about the acceleration? How you will find this is about the velocity, and what will be the acceleration? Okay, acceleration. Yes.
change in velocity.
Yes. Not leave it. The first derivative of velocity is defined as acceleration, as I have already explained. I think I don't need to repeat it again and again. If you change the derivative of first derivative of position, that will be give you velocity. If you will take the double derivative of position, that will give you the acceleration. Okay. So the second.
आपने शुरू में बताया था कि हम जो फ्रेम ऑफ रेफरेंस ले रहे हैं वो है इनिशियल initial to go there is acceleration 0. Now acceleration you find out.
1 minute. Okay. Velocity, the velocities of the frame of reference must be a constant, not a plane.
आपने कहा था initial frame of
Inertial frame of reference. Inertial frame of reference. The velocity between the relationship between the velocities between the frame of references must be a constant for frame of reference. VB, okay, 1 minute. If we take consider Z1, okay. If you consider Z1, that is VBA minus plus VB. Okay. If you take the derivative, this will be a dVA over dt. This will be a 0 because it is constant. This will be acceleration A and this will be acceleration 2. Okay? Got it?
Yes, sir.
So, acceleration for plane. If there is acceleration, if plane is moving with some speed, I am not saying the velocity of plane is constant. I am saying that my claim was that the frame of reference velocities will be constant. Okay? The relative velocity between these two observers are a constant. They are not increasing the speed. Okay? If the velocity of these two masses is constant, they will be observed different velocity. But according to their observation, acceleration will be a zero. Okay. So acceleration of planes with respect to observer A will be same as acceleration of plane with respect to observer B. So there will be no change in acceleration. So if I consider that it has a mass m0, if the plane has a mass m0, if we multiply m0 both sides, then I may say that if I multiply both sides with the mass plane, okay, with the mass plane AP, the force will be same, even force will be same. Okay. They will be observed the same forces, okay, for this. These are called the Galilean transformation. Okay. Okay. These type of transformation is defined as Galilean transformation. These, okay, may I drop it?
Yes. So काफी है.
काफी है.
One. These transformation is defined as, या स्पेलिंग देख लेना गलीलियन के मेरा ख्याल है. These type of transformation will be defined as Galilean. Okay. Size is if two masses are moving as shown in figure में मैं बता देता हूँ, ठीक है? Find their velocities. Okay. एक्सप्लेन नहीं किया क्या, लेकिन जैसे फिगर में दिखाया गया, इफ समथिंग इज मूविंग एट इस एंगल मेकिंग इट थीटा, ओके, if this is a with velocity v, if something is moving with the velocity a, okay, let's suppose the other mass is other particle is b, okay, if a is moving with velocity a and making angle theta, if b is moving with the velocity b and making angle theta b, ठीक है, okay, VA and VAB and VB. Then you have to find these, okay? Relative velocity. Okay? So this is figure A given, okay? This is given. Now you have to find the solution. Okay? How you may find the solution? Yes. We may join it with the head and tail rule. So, according to head and tail rule, this is VA making angle theta A, yes, and this is, yes, Muslim. This is the velocity VB, and this is making angle theta B. Okay. Yes. So you have to find this is this. You have to find VAB. Yes. Firstly, VAB. What is the VAB?
Velocity of mass A with respect to B.
B, and that will be a velocity of observer, velocity of A with respect to B. Yes. And what is this? This I have already proved that VAB will be equal to in Galilean transformation. We have proved that this is equal to this. Yes? In Galilean transformation, in the last time we have proved that VAB is equal to this. Yes? And VBA is equal to VB minus VA. Yes? These two formula we have derived in the last time. Okay? Yes? Okay. But if I join this with this, this will be VA plus, and the head joining with the head and tail joining with the tail. Yes? And this will be VA plus VB, and that is not our requirement. So we don't need it. This is not wrong, but we don't need it. Okay. We are not interested to find it. Not interested. Yes. But we are interested to find this. Yes. And this. We are not interested to find this, but interested to find this. How we may find it?
by table.
Yes, but how? The question is how we may
सर
find
ए
it.
बी का जो रिजल्टेंट होगा वो उसको
No. Firstly, we have to write VA, okay, then VB. Okay. This is VB, okay, and we have to add minus VB in a VA because we have to add minus because this expression is actually TVA. As I have already told, I have already mentioned many and many times. Addition is actually the subtraction is actually the addition of negative number. Okay, so I may write it in the form of VB. Yes, and negative VB mean this is the positive, or negative VB mean this, and this will be a minus VB. Okay, this is a VA, this will be a minus VB. Yes, got it? And this is was making angle theta 1, this was making angle theta A, this was a theta B. Yes? So okay, and this will be actually VAB, that is equal to
VA minus VB.
VA.
तो सर VA की तो रिवर्स फ्रैक्शन की तो
VA और this is B.
सर इसकी तो रिवर्स होगी
1 minute.
डायरेक्शन
ये VA के लिए B को माइनस करना है, इस वजह that's why we have it.
ये हमारे पास प्रोडक्ट
VA, this is VAB, this is
सर जो VA नीचे लिखा है आपने
ये नहीं, ये VA नहीं है, सॉरी मैंने गलत लिख दिया. This is a VA, this is VAB, VA minus VB. Okay, because this is VB, this is minus VB.
हमने वेक्टर जो B
So that's why we have taken, according to Atta-ul-Latif rule, this is the resultant of the, actually this is the resultant of VA plus minus VB. This is minus VB, and so this will be equal to VA minus VB. That's why. Okay.
हमने दो में